I am Nipesh from NIT Mizoram. Let me zoom this poster so that you can read the details clearly. This is the title of my presentation: the structural, dielectric and ferroelectric properties of BIF 0.95 SM 0.0.5 O3 ceramic, which I will refer as BFSO ceramic. So this BFSO ceramic, it was identified as a desirable lead-free candidate to replace lead zirconia titanate in multifunctional electronic applications because it exhibits both high remanent polarization and great ferroelectric properties. Now we will come to this result and discussion part, and when we talk about this structural studies, we can see that the crystalline structure of compound carried out through powder X-ray diffraction, and it confirmed the formation of a single phase orthorhombic system at room temperature. The average crystal size, it was calculated with the help of Serre formula, which was around 39.96 nanometer. Okay. The structural lattice parameters symmetry were resolved and refined from the PowerMelt software. Now we will go to this SAM part. From this image we can see that grains show sub-micron size, very dense and non-uniformly distributed throughout the surface of the sample. The grain size has been measured using image software, and the nature of quite different shape and size of grains, it indicates the existence of polycrystalline nature of material. Okay, so now we will go this frequency dependence of dielectric characteristics. Okay, that is epsilon r and dielectric loss tan delta. The dielectric study deals the subject of relative permittivity epsilon r of the specimen with definite dependence of frequency and electric field relying on the class of polarization which is responsible for flaws in the synthesized compound, relaxation, etc. Relative permittivity epsilon r is the fundamental and essential factor of dielectrics. It is a complex valued quantity which is mostly subjected to the frequency and operational selected temperature. At low frequency region, the large dielectric constant values are mostly because of the dipolar polarization and space charge. Here you can see that at lower frequency we are having a higher value of this both dielectric constant epsilon r and tan delta. And when we come to temperature dependence of dielectric constant, in this plot we can see a peak. It is observed around 425 K. It is representing the presence of ferroelectric phase transition in the synthesized compound. Okay, now we will go this electrical conductivity. This is frequency dependence and this is inverse temperature dependence. For frequency versus conductivity plot, the strong dispersion nature occurs at a low frequency range and conductivity rises with the increase of frequency. Okay, and here this is our AC conductivity with respect to inverse temperature. And here we will talk about this in this graph: variation of real Z prime and imaginary Z double prime impedance with frequency. The experimental data of impedance has been analyzed with an appropriate equivalent stimulated circuit by exploiting the Z-Symphony software. An equivalent stimulated circuit consists of parallel association of CR and CQR circuits to record the experimental as well as fitted impedance data. At lower range of temperature, the Nyquist diagram is not detected, whereas at the higher range of temperature, the occurrence of single semicircle R appears. For most of the composition, it proves the occurrence of single conduction process. Okay, this is the objective of this work, and this is the experimental method. Okay, these are some references, and this is the conclusion of my poster. Okay, thank you all.